This video is on building higher terms. Adding fractions when denominators are different requires a least common denominator, and we must build the higher terms to make a fraction that is equivalent to the original with that least common denominator. So this video is going to discuss building the higher terms. So let's first recall the fundamental theorem of fractions, or the fundamental principle of fractions. We discussed this when we were reducing fractions. So the fundamental theorem of fractions then was using the division, but now we're going to use the multiplication. So if you multiply or divide both the numerator and denominator by the same number, the fraction you will be equivalent. So we're going to have a fraction a over b, and we're going to multiply it by c in the numerator and c in the denominator, and we will get a new fraction that will be equivalent to the old. And as long as the c is not 0, that will be 100% true. So building higher terms goes like this. You're either told what the new denominator is, or you determine by finding the LCD. Then you ask yourself, what do I have to do to multiply my denominator, or what do I have to multiply my denominator by, not do, what do I have to multiply my denominator by in order to get my new denominator? When I find that answer out, that's my C. Another way of asking that same question of yourself, what do I have to multiply by in order to get my new denominator, that is just dividing the new by the old. That is the same exact operation. And then once I get that new c, then I multiply my numerator by the c as well, and I'll have the higher term. So let's practice that. So if I have 5/7 and I want to build it to an equivalent fraction with a denominator of 14, I have to find out what that c is. What do I multiply by here in order to get that? So I can ask myself the question, 7 times what is equal to 14? Well, 7 times 2 is equal to 14, right? And again, another way of asking that is new 14 divided by old 7 is equal to what? And that what is my c, and it's equal to 2. So now that I know what c is, I have to do the multiplying of both the numerator and the denominator. That's just the fundamental theorem of fractions. Another way of looking at this is all I'm doing is multiplying by 1, because 2 over 2 is 1, and any number multiplied by 1 is going to be the number itself. That's why the fundamental theorem of fractions works. Now to get my new numerator here, I multiply out. 5 times 2 is equal to 10. So there we go. My equivalent fraction to 5/7 with a denominator of 14 is 10/14. Now, one of the things that students frequently do when they build higher terms is they want to turn around and they want to reduce it back down. But that would kind of defeat the purpose. So just remember that. If you're building the higher term, then you don't want to turn right back around and reduce it. How about you try 7/8 to something 56? Okay, so I ask myself, 8 times what is equal to 56? Well, 8 times 7 is equal to 56. Remember, that's the same thing as saying 56 divided by 8 equals what? And that is 7. And that, of course, is what my c is. So I'm multiplying the denominator by 7, so I must also multiply my numerator by 7, because I can't change my fraction. So now my new numerator is 7 times 7, which is 49. So my equivalent fraction to 7/8 is 49/56. And that's how we build a higher term. Now we're going to apply that to fractions. So if I have 1/4 and I wanted to add it to 1/10, I can't do that because these denominators here are different numbers, and denominators of fractions don't add up. We have to have a like one so we can drag it along with us. So what we're going to do is we're going to find a least common denominator so that we can then decide what our higher term needs to be based upon. So remember, from if you've watched the Finding Least Common Denominators, 4 is equal to 2 squared, and 10 is equal to 2 times 5, and our least common denominator, therefore, is going to be made up of the unique factors of 2's and 5's, and 2's highest exponent is 2, and the 5's highest exponent is 1, and now we have 2 squared times 5, which is 20. So my least common denominator is 20. So what I'm saying is that I'm going to build myself some higher terms here. I'm going to build myself higher terms with 20s. I make the problem this time. So I'm going to make 1/4, and I'm going to make 1/4 into something 20ths. And I'm going to make 1/10 into something 20ths. So let's start with the 1/4. So I asked myself here, what times 4 equals 20? Well, the answer to that is 5. So what I do to the denominator, I do to the numerator. So 1 times 5 is equal to 5. And there's my higher term. Now I'm going to do the same thing for the 10. What times 10 equals 20? Well, that would be 2. So whatever I did to the denominator, I do to the numerator. 1 times 2 is equal to 2. And now I have a problem that I can add together because the denominators are the same. And 5/20ths is equivalent to 1/4, and 2/20ths is equal to 1/10. And that's how we'll be applying this. You might want to try one on your very own. Let's give you one to try, and then you can come back and see. Let's do that one problem that I did. Let's see, I think it was maybe 7/18 plus 5/24. Let's see if you can do that one. So you should pause the video and then come back and look at it and see how you did. Okay, the first thing I'm going to do is find the least common denominator. This, remember, is 2 times 9, and this is 3 times 3. So this looks like 2 times 3 squared, and 24 is 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3, and so this is 2 cubed times 3. So my least common denominator is going to have 2's and 3's in it, and the number of 2's, the highest exponent, 3, and the number of 3's, the highest exponent, 2. So this is 8 times 9, which is 72. So I'm going to be building higher terms to 70 seconds. So 72 is my new denominator, 72 is my new denominator. So I have 18 times what equals 72? Well, if you find that really hard, don't get all freaked out. Come and look at your prime factorization. I already have 1 2. How many more 2's to get 3? Well, that would be 2, right? So I would have 2 times 2 more. And I've already got the 3 squared, so that's what I have to multiply by, 4. So if I multiply 18 by 4, I'm going to get 72. So 4 times 7 gives me my new numerator here. Now let's go do it here. So again, don't freak out. You see 2 cubed, I've already got it, right? And there's 1 3 here, and I need 2. So I'll have to multiply this by 1 more 3, won't I? So 3 times 24 will give me 72, and 3 times 5 will give me 15. And now I have higher terms that are equivalent, right? This is equivalent to 7/18. This is equivalent to 5/24, and I'd be able to add those together. And you already know how to add fractions with common denominators, so you're ready to go at that point in time. So this little trick, you might want to practice this so you don't have to pull out a calculator every time. Let me do another one for you that you might see yourself using that. Let's do 3/18 and I don't know, let's do 6/27. Maybe that would be a good one. So 18 we already have, right? That's 2 times 3 squared. And then 27 is 3 cubed. So the LCD in this case is going to look like 2 times 3 cubed, or 27 times 2, which is 54. So as we build these two 54ths, how would we get there? So what you do, again, just going over this little trick here, what we have is we have 2 times 3 squared. Well, we need 2 times 3 cubed. So how many 3's are missing? That's right, if you said 1, right? So 1, 3, right? That'll make the same as up there. So you multiply this by 3, so you'll also be multiplying that by 3, which gives us our new higher term. Now here with the 27ths, right? This is there. What's missing is the 2, right? So times 2 will give us the LCD. So this times 2, and so this times 2, which would give us the 12. Okay, so that's your little trick. Hopefully that will help, and now you'll be ready to add fractions with unlike denominators.